team. Great news. A big client wants a platform upgrade. We're starting with React, TypeScript, same usual.
Oh, let's rewrite it in Rust for better performance, all right?
And GraphQL for the API.
Okay, add it to the backlog.
Where is this even going?
Everyone
Who's
thinks
gonna
we
do
need this
it?
client.
Rust.
Haven't we already found a solution?
Yeah, not the best.
Hey, let's hear what the team has to say.
Hey! Just got off the call with the client. They want the app on all platforms.
Oh, shit.
Maybe Kotlin multi-platform?
Hey, guys, I sketched out a Kubernetes and service mesh setup.
All right, let's take this one step at a time.
We need real-time sync. I say we set up
This
a
is
Kafka
the third
cluster.
version of the module this week.
And okay, let's do it.
Hey guys, meeting.
Oh, here we go again.
All right, let's cut to the chase. We've got coordination issues. Let's implement scaled agile.
And the client wants AI recommendations.
We should set up a CI/CD pipeline.
And let's add PWA.
Okay, any other ideas?
We need solid principles, or this thing will be a nightmare to maintain.
Why the hell aren't we doing event storming first?
Service
we
mesh?
need a
It's the
proper
only way
domain
we're
model.
scaling this.
Wait.
Scrum of
Guard,
scrums.
form,
We need better
mobile,
coordination. This is
cross-platform
chaos.
is a disaster without it.
Listen
Oh,
to me,
no,
please.
no,
This
no.
makes sense.
I'm not getting serious.
I've already explained
The
it.
project didn't launch. The client is replacing the team.
Oh my God.
What?
Hey everyone, this is Alex Antanuk and welcome to the pilot episode of the Agile Redemption. Today's topic is Overengineering.
When chaos tears processes apart and teams wander in search of the truth, there comes a moment of change.
Welcome to the Agile Redemption, a podcast about software delivery, engineering practices, and the sins we commit in their name.
There are timeless questions in the world. Which came first, the chicken or the egg? Where does space end? And why do teams make even simple check problems 3 times more complex than needed? Figuratively speaking, instead of building a regular highway bridge over a river in Africa, they construct a Brooklyn bridge with restaurants. No one remembers why anymore, but most importantly, no one considered that the metal's heat resistance needs are different from New York's. It's not just startups that fell into this trap. Even giants did in the early days of e-solutions. Businesses don't like to recall such things, and often it's a trade secret. But it's known that in the 2000s, BMW released a complex iDrive system that made the car almost impossible to use without instructions. And the FBI, due to uncontrolled development, buried its most ambitious database. And after burning through $170 million, had to restart the project from scratch. In general, such mistakes are expensive. So expensive that NASA listed overengineering, both in hardware and software, in their top 10 major threats to projects. And what about the stats? Not many relevant studies are out there, but last decade's data, which people still quote today, shows that almost a third of banking software features are over-engineered. More recent data backs this up. Pando's 2019 report shows up to 80% of features in average software were rarely or never used. And public companies blew nearly $30 billion developing them. But here is the thing, not everyone in tech sees this as a problem. Over-engineering is a Hollywood topic even within companies. Some managers fight it, others don't acknowledge it, and some even think it can be useful. The international expert community doesn't have a unified opinion either. It seems they tend to see it as a harmful, but define it differently. What exactly counts as over-engineering, where its boundaries are, and how to work with it. For example, the well-known theorist Martin Fowler writes, "There is a notion that design is something you can trade off for greater speed. If it were the case that putting effort into design reduced the effectiveness of programming, I would be against it." In general, Fowler is for compromises. He thinks that both over-engineering and tech debt are sometimes needed for business, although you need to consider the specific situation. The pioneer of continuous delivery, Britt Dave Farley, sees a big difference between quality design that leaves room for change and over-engineering that tries to precisely predict the future. In other words, between building a house with the possibility to add rooms and building 10 extensions from the start that may not even be needed. Meanwhile, American Robert Martin cuts straight in job style. Simplicity is the ultimate sophistication. At the same time, he insists on architectural perfection as he sees it. Clean code, framework independence, modularity, and solid, even if it's more expensive and complex at the start. His belief is that good design is laid down from the beginning and pays off in the long run. Roughly speaking, the breeds Fowler and Farley here are flexible pragmatists, not fitting the stereotype of over-regulated Europeans, while Uncle Bob is more like the sheriff of strict US corporate rules from the 90s. Though Fowler was making his career back in pre-startup America, and Martin, seemingly an old-school engineer, stood at the origins of Agile in the 2000s. Well, even gurus contradict themselves sometimes. That's why today's topic about relativity is quite something. And from us, we'll do what we can, different opinions. So, draw your own conclusions, friends. By the way, speaking of the old world, we are recording our podcast right there, so we've collected the opinions of some European practitioners. What do they consider over-engineering? The first comment comes from Maxim Leikin, head of engineering at the Estonian company Bamboo Agile.
I wouldn't say there are exact criteria, but at least there are markers that can make you think about potential over-engineering. The first marker is an attempt to reinvent the wheel. For example, if a client asks to develop a new marketplace mobile solution or hotel booking system, we should assume there must be many open source frameworks that can be easily and quickly customized per client requirements, and the overall effort will be 10 times less than developing it from scratch. Another marker is an estimate given by the developer for the task. If it seems enormously big, there is a good chance that the task is overestimated due to an over-engineering approach. And this is where a solution architect or engineering manager should step in effectively. And the third marker is buzzword magic. There are certain buzzwords nowadays like microservice architecture, AI-based solution, voice assistance, and sometimes a willingness to use these trendy approaches can also lead to over-engineering.
Maxim's colleague, CEO of Bamboo Agile, Sergey Zubovich, approaches the question differently, seemingly not fully acknowledging either over-engineering or excessive simplicity.
I appreciate the point about over-engineering, where solutions become unnecessarily complex. However, my recent experience has made me rethink this. In many cases, I would prefer to call this approach not engineering rather than over-engineering. What makes a great engineer? Whether in tech or traditional fields, the ability to build a solution that corresponds to functional, budget and time requirements, the ability to find the right balance between competing factors, and in an ideal world, the ability to ensure that the solution will serve for hundreds of years with proper maintenance. It's impossible to have all the indicators turned up to a maximum. That is why following this approach leads to a long list of trade-offs. Those who try to include everything in their solution and do it right away without aligning with reality are probably neither engineers nor over-engineers.
Martin Sittema, CTO and founder of Dutch service CaterMonkey, suggested in the Fresh Code podcast to separate over-engineering, which he sees as excess engineering solutions, from perfectionism. Sittema thinks that latter can be even riskier, for example, when it comes to deadlines.
You always have perfectionism. Maybe that's the word. Over-engineering something else is perfectionism, but perfecting things is not always like perfect, because then often the time scale is ignored in perfecting something. And by not meeting time goals, because you're perfecting, you're failing in a way.
A non-European but also well-known developer Eliran Turjman explains over-engineering from the grassroots as a choice to code too future-proof and not making it future-proof at all. In his article, the Israeli author gives the example of customizing shopping baskets, where special-purpose code can quickly become confusing, but code that is too general can quickly complicate things. We'll discuss what Turjman suggests as a way out a bit later.
The Agile Redemption.
So we seem to have figured out what overengineering is about. But is it really such a problem? Should we fight it, or can we, for example, use it? In 2019, a team of researchers from several countries, USA, Britain, Sweden and Italy, published a report, Software Development Beyond Customer Requirements. And they didn't mention the phenomenon was definitely harmful. Rather, it has both pros and cons. Like, on the one hand, overengineering provides flexibility in the face of uncertainty. On the other, it quickly becomes irrational, and so on. The main idea here, overengineering can theoretically be managed. But that wasn't the end of the story. 3 years later, one of the authors, Italian researcher Giacomo Marsi, released a new report. This time he was much more critical of overfeaturing, which he linked, among other things, to IT overengineering. Citing industry examples, he called it a pathology that leads to feature fatigue, delays, and overall quality issues. Therefore, according to Marsi, the right strategy for overengineering is to fight it. By the way, in this work, the Italian researcher relied on a greater number of parameters, including market data, so in essence, the report is broader than his and his colleagues' earlier study. Okay, that's what theorists think. What do practitioners say? Some believe much depends on the stage of a company's development. For example, Code Scene founder and Your Code as a Crime Scene author Adam Thornhill argues that in the early stages, overengineering might not be a problem at all. Instead, the real issue could be a lack of it, and brings up an example from his own experience.
In the first days of CodeScene, we decided that we wanted to be very simple to get started with the tool. I don't want you, as a potential user, to start to, install databases left and right. So we choose an embedded database. But then we found later, as we scaled up and start to take on large enterprise accounts, that we simply couldn't meet their needs with an embedded database because it's really hard to do a backup of it. It's really hard to, do a restore of it and all that. We kind of have to rethink that space and make sure we could support external databases that you connect to and all of that. So,
according to Thornhill's experience, the solution chosen today almost always looks poorly thought out 2 years later. And this is more distinctly noticeable in startups. Maxim Lakin from Bamboo Agile thinks similarly and considers under-engineering even more dangerous than over-engineering, regardless of the company's size. He provides an example from a project where his team had to decide how to technically notify mobile clients about new events from the backend.
There were 3 options: long polling, WebSockets, and push notifications. We went with the third one, since it seemed like the simplest and fastest approach. Later, we regretted it when we realized that push notification delivery on mobile platforms wasn't stable enough. Plus, iOS had limitations on receiving notifications when the app was running in the background. So we had to switch to WebSockets and spend additional time on implementation, while the time spent previously on configuring push notifications was wasted.
Here is another example where overengineering was rather appropriate. Maxim recalled developing an Android app for configuring hydraulic machines via NFC.
Initially, they asked for an extremely simple solution that would support 3 particular models of machines, and all parameters had to be set manually in the app. Instead, we proposed developing some kind of a web interface to be able to prepare configuration files with machine parameters using graphics user interface, validate them automatically, and only then upload them to the mobile app. Our arguments focused on the versatility and reliability of the solution, whereas the client just wanted to keep the project budget as low as possible. After quite lengthy negotiations, they accepted our proposal, and about a year later, they got 5 new machine models with different configuration parameters. Thanks to our pre-validated scheme, we saved much of their and our time to accommodate new hardware.
According to Maxim, this solution was inspired by simple thought. He imagined a heavy hydraulic press falling due to typo on a smartphone. But such cases are rather an exception. Therefore, he usually doesn't consider himself a fan of complications. Maxim's colleague from Bamboo Agile, Sergey Zubovich, is tougher in his assessments. Throughout his entire experience, he has not encountered a case where over-engineering, or as he says, not an engineering, has led to anything other than budget exhaustion, deadlines being missed, maintenance difficulties, or all of the above at once.
The Agile Redemption.
Okay, if we agree that over-engineering is still a problem, what are its causes and how do we fight it? Remember the 2019 study? Its authors came to an interesting conclusion. Over-engineering is more of a psychological phenomenon than a technical one, and directly depends on the personality types of the engineers. After surveying 307 specialists, they identified 3 components of predisposition to overcomplication: cognitive, emotional, and behavioral. Developers with an intuitive thinking style tend to keep adding new features to a product relying on subjective judgment. In reality, the features might be interesting but are often barely used. Rationalists, on the other hand, gravitate toward logical and universal solutions and get carried away trying to please everyone or account for every possible scenario. Personal emotional attachment to a project amplifies both types of success. Experience, however, works differently. For some, it reinforces reliance on outdated practices, while for others, it improves risk assessment based on past mistakes. The survey authors advise considering these characteristics when assembling development teams. And Giacomo Marsi, having explored the issue further in 2022, formulated more precise recommendations. They fall into 3 categories: managerial, process-related, and technical. As managerial recommendations, Marsi suggested avoiding uncontrolled expansion of both the project and the product, managing requirements flexibly while ensuring their validity. To achieve this, he recommended integrating into processes both agile and stage-gate methodologies with a focus on cross-functionality, clear criteria for core MVP principles, and strict task prioritization. And on the technical side, testing prototypes at early stages, following overall minimalism in development, and thoroughly analyzing each feature before implementation. Essentially, Marsi's key approach is a balance between flexibility and control, with a focus only on the essentials. Other theorists argue that not only the methodology and processes matter, but also team structure. In 1967, programmer Melvin Conway formulated a law stating that companies design systems mirroring their communication structures. Simply put, the more complex and distributed the team, the more complex and fragmented the project. Can it be challenged? Of course, the law is quite old. On the other hand, in 2015, MIT and Harvard Business School published a study confirming its relevance, and industry leaders seem to be taking it into account. Not long ago, Jeff Bezos' approach to team structuring at Amazon was widely discussed.
We try to create teams that are no larger than can be fed with 2 pizzas. We call that the 2-pizza team rule.
It must be said, the rule has faced plenty of criticism. Its core idea is that truly effective decisions come from teams small enough to be fed with 2 pizzas. Still, former Amazon seniors Colin Breyer and Bill Carr write in their book that, while the approach has, in their view, lost some relevance, it still works well in development, specifically as a way to prevent over-engineering. Elon Musk has his own views. It's well known for demanding that teams at Tesla and SpaceX don't get stuck in their own ideas, but actively share them with each other. The billionaire calls this a fight against silos. However, both Bezos and Musk advocate for simplicity, not just in communication, but in everything. They often urge both managers and engineers not to spend months on decisions that can be reversed.
The design takes a long time to build, it's the wrong design. Over and over, it's like the tendency is to complicate things. The best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong.
Meta founder Mark Zuckerberg became famous in his time for a different approach. In Facebook's early days, his teams used the slogan, "Move fast and break things," releasing code daily, consciously allowing mistakes, but also outpacing competitors. In this wild race, Zuckerberg saw the key to learning through action, which later translated into another motto: "Done is better than perfect." But times change, and in 2014, Zuckerberg announced the maturation in his views.
As the company grew, we were producing so many bugs that going back and fixing them was actually slowing us down more than we were speeding up. So I still thought, okay, like moving fast, this is still like a really important thing. We've got to change how we do it. So we kind of evolved to building a somewhat less sexy phrase, move fast with stable infrastructure. And basically the new bet was we were going to invest disproportionately in building up good infrastructure and abstractions inside our companies, so that way the average engineer who comes here is going to be much faster and more productive at getting things done than in other places.
It seems Zuckerberg, like other new wave tech leaders of the 2000s, largely followed the ideas of popular analysts at the time, blending them with his own complex experiences and those of his competitors. Let's look at this generally. Martin Fowler advocates for evolutionary development. His main principle is continuous code refactoring, but gradual and only when truly needed. A classic example is Twitter's Story. Their first Ruby on Rails monolith handled only 200 requests per second. Of course, problems came later. By the time they switched to microservices, the load had grown to 12,000 tweets per second. But the company had managed to develop a business model and find resources for re-engineering. Dave Farley, with his automation credo, suggested that instead of trying to predict the future, we should create an infrastructure that quickly implements the changes when needed. Netflix has something similar. Their architecture isn't super reliable, but can self-recover after failures. Their Chaos Monkey tool deliberately breaks production, but it always recovers, on average in 7 minutes. And this happens constantly. In essence, Netflix is a large crash test site. Did you notice anything while watching your favorite series? Robert Martin, known as Uncle Bob, immediately offers a strict criterion. If you spend more time on design than implementation, you are already in the over-engineering zone. Even Google, with their strict standards, considers the simple solution to be the best. In their internal documentation, there is one requirement: a new developer should be able to understand your code within a sprint. Can't do it? Then something is wrong. Bottom line. The classics understand engineering quality differently, but they almost always agree on one: simpler and less is almost always better. The rest are details. Taking this as a base and roughly combining all approaches above, we will highlight several key principles from experts based on their literature. The first is the principle of proven necessity. Here is how Robert Martin explains it.
You only put in the abstractions that you need, that you provably need. You will find that you will put a lot of them in just because you're writing tests. The tests will need a lot of abstraction so that you can decouple your production code and get inside it and access it from unit tests. And then you'll also find from time to time that there are changes that people make, and you'll look at your code and go, man, I didn't protect myself from that. So that's when you do it. You go back and you refactor that abstraction in. It's pretty reactive. There's a little bit of upfront design work at every iteration, a little bit of abstraction that you think you're going to need, but not very much.
More of Martin's philosophy is reflected in the already mentioned solid principles. Essentially, he was the one who defined them. Fowler's vision, on the other hand, aligns more closely with another well-known concept: YAGNI, or you are not gonna need it. The second principle is the balance between speed and quality. According to Fowler, technical debt is acceptable when it allows for faster validation of business hypotheses. This is also the basis of extreme programming and its related practice, pair programming. The third is a nod to Farley: automation as an alternative to excessive design. The focus is on systems that are easy to test, deploy, and recover. A well-known classic example is Amazon. The fourth, and most important, is a focus on the present. All three authors agree that trying to anticipate future needs more often creates problems than solves them. The Israeli author and Microsoft developer Eliran Turjman illustrates with a practical example how these principles work in action. We mentioned him earlier. In his article Finding the Right Balance, he presents a case on configuring shopping carts in an online store and describes 3 approaches with screenshots. The first is straightforward, using specialized code. Developers create a separate method for each case of item removal. One deletes an item by ID, another clears the entire cart, and third removes out-of-stock items. The code works, everything is simple and clear. But then a new requirement appears, and another method is added. Another requirement, another method. Over time, the class grows with methods that are essentially identical, increasing cognitive load for developers. This results in under-engineering. In this case, solving each new task with a separate method without considering future code maintainability. Approach 2. The bloated standard solution. After getting burned by the first version, developers create a super universal deletion method. It takes not just a deletion condition, but also an external service for rule validation, additional filters, and event handlers. Not bad, but now To simply remove an out-of-stock item, you have to write something like that. Delete where item is out of stock, rule service equals null, filter equals standard, handler equals null. And this is already over-engineering, a solution so generic and flexible that simple operations become hell. Approach 3. The conditionally balanced. One deletion method that takes only a condition, the rule that defines which items to delete. Want to delete an item by ID? Pass the condition where ID equals given. Remove out-of-stock items? Condition where item is out of stock. Clear the cart? Condition delete all. The code remains relatively simple, quite understandable, yet flexible enough for all real scenarios. Okay, let's return to Europe. We asked our fellow practitioners to share how they would advise avoiding over-engineering. Maxim Lakin, head of engineering at Bamboo Agile, Estonia.
There is no one-size-fits-all rule. Each project is different. However, in general, to avoid over-engineering, it's useful to stay informed about the best modern trends and practices, like service-oriented or event-driven architecture in software design. Always think about reusing something instead of writing it again, and discuss ideas and approaches with other team members before coding. I know that many teams practice test-driven development, which helps prevent redundant coding. Though I am not a big fan of test-driven development myself. Still, it might be the way forward.
Maxim's colleague, CEO Sergey Zubovich, believes that simpler solutions are always more open to becoming complex than vice versa.
Old-school engineers prefer to invent each particular screw under the hood and, for example, apply such things as Kubernetes and microservices wherever they can, not really caring whether they are necessary or not. Often this way, they solve the non-existent business case of migration from one cloud provider to another. This is just a specific example, and you might disagree here. In general, I would advise always keeping in mind the KEYS principle. Keep it simple, stupid. And CAP theorem, which stands for consistency, availability, and partition tolerance.
Bamboo Agile's engineering manager Vasily Ninko advocates for an evolutionary path following Fowler's principle. In his opinion, the key criterion for a technical solution's success, how well it allows the business to develop, becomes clear only in a year-and-a-half perspective.
I believe that if a system can operate in a simpler way, it should. This doesn't mean it should be crude or lack the ability to evolve. In fact, it's an exaggeration to claim that everything magical needs to be built from the start without room for adjustment later. Partly for this reason, I don't think it's useful to blindly follow all client requirements. Any task can be viewed as either more general or simpler.
Vasily cites a Polish payment system that serves most of the country's banks and online stores using only 2 microservices. But he reminds us, simplicity must be deliberate. That's why he advises caution with low-code development.
The Agile Redemption.
So, friends, let's sum it up. Of course, there will be no unambiguous answers. We have presented rather general views. But let's try to summarize the key points. Over the past decades, 2 polar approaches developed in the tech industry. One is to anticipate everything from the start. The other is to do only what's needed now. As is often the case, the truth lies somewhere in the middle, and there are no universal rules of the game. What do theorists and practitioners from different countries agree on? First, there is no universal solution. What is over-engineering for startup is critical for an enterprise system. What's optimal for one niche is impossible for aviation or banking software. And even what's brilliant in functional simplicity now may ruin your system in 2 years. Second, not only is over-engineering harmful, but so is opposite extreme. It's useful to consider the psychological aspect too. Third, and perhaps most importantly, success lies in a delicate balance between Netflix's let it fail but recover quickly and Google's figure it out in a sprint, between early Twitter's monolith and Amazon's service-oriented architecture. The balance is fragile and individual, but nearly always rests on the 3 pillars. Understanding current, not business requirements. Ability to change quickly when needed. Common sense in risk assessment. How to achieve this then is a topic deserving of another podcast. For now, let's take Martin's time-based criterion as a rule of thumb. If you spend more time designing than implementing, you are probably overcomplicating something. And if you made a mistake, Well, you can avoid mistakes only if you do nothing. The key is to recognize it and fix it in time. And that's what we wish for you. Thank you for being with us. If you enjoyed the episode, subscribe to the Agile Redemption on Spotify and other platforms. And share in the comments, if available, what cases of overengineering or underengineering have you encountered? And what did they cost you? This has been Alex Antonuk. Until next time.
The Agile Redemption.